calculus 1, mainly differentiation, and our first topic will be power rule differentiation. So who can tell us what it means by differentiation? Anyone of you? Yes, colleagues.
Differentiation is a process in calculus used to find the rate of change of a function of a variable.
Very nice. Nice response. Any other response? Giant, Cheryl? Any idea? No, sorry, go on. Okay. Now, differentiation, as colleagues has stated, is a process in calculus used to find the rate of change of a function with respect to a variable, normally, oftenly, x. Okay. Under differentiation, we have what we call power rule differentiation. Let's say we've been given a function of x to be x raised to n. Now, how do we go about power rule differentiation? This one, x is our variable. Are we together? And then n can be any real number. Can be a positive number, be a negative number, can be a whole number, can also be a decimal number. Okay? Yeah. Now, the formula for power rule differentiation is given by d of dx into bracket x raised to n is equals to n x raised to n minus 1. Now, I'm going to explain it now. Steps for using power rule. Okay? Step 1, identify the exponent x. What do you mean by exponent? Exponent is inamaanisha, let's say a variable has been raised to a certain number. As we said earlier, can be any number. Our exponent here is, are you seeing this? Our exponent here is n. This is our variable. Now, after identifying the exponent n, bring down the n as the coefficient. Like I said before, what do you mean by coefficient? Say, let's say given a function y is equals to 3x. Who can tell me what is the coefficient of x here? Coefficient of x? 3. Yeah. So when I say bring the exponent, bring down the n as the coefficient, what do we do? This n here, now let the variable x. And then you rewrite the x, then you minus the exponent minus 1. We'll do it practically so that you can. Yeah. So this is just typically the process. Now, example 1. Let's say we're given a function f of x is equals to 5. X raised to 5. X raised to 5. We will go to differentiate it using power rule. It will be 5x here. Then the power subtract 1. So our answer will be 5x raised to 4. We can also go to the other example, example 2. Let's say we given a function f of x equals to 3x raised to power 4. We differentiate this one. Bring down the 4 here. It will be 4 dot 3. Dot in mathematical terms, it means multiplication. So it will be 4 dot 3. Then you rewrite the x, the variable. The power you subtract 1. So when you simplify this, it will be 4 times 3 will be 12. So our answer will be 12x cubed. Are we together at that point? Yes. Anyone with a question? So up to this point, are we together? Yes. So let me. Okay, yes, Jack. You have any question?
Yes.
Nice.
So my question is.
Yes.
Kindly repeat the example 2. I didn't get it well.
Example 2. Okay. So like I said earlier, given a function of x is equal to x raised to power 5. The first step is to identify our exponent, the power. You identify the power. So our power here is 5, isn't it? Bring it down as a coefficient. So if you bring 5 down here, it will be 5x. And then the power, which was 5, you subtract 1. So our answer will be 5x raised to power 4. As simple as such. Are we together, Jai?
Yes, and another question.
Yes.
Exponent. Is that as does it mean the same as power?
Yes. I think I mentioned that earlier. Maybe you are not so attentive. I mentioned it. Okay? So, we have another example. Y is equals to a quarter raised to power 4. So when you differentiate this, it will be d of y dx. I normally write dx because we are differentiating our function with respect to x. Yeah. So we'll be bring the 4 here down as the coefficient. It will be 4 dot a quarter x. Subtract 1 from the 4. 3. 4 minus 1. So when you simplify all this thing, it will be x raised to 3. And we are done.
I have a question.
Yes.
So in that case, the coefficient is 1 over 4.
Originally, the coefficient of x raised to 4 is a quarter.
Okay.
So when I bring this down to act as our coefficient, it will be 4 times a 4. So in simple time, you have to simplify this. You cannot leave a function as this man. Okay?
Okay.
So when you simplify this and this will cancel. Okay? You remain with 1. But you did not decide to write 1. Just write x. Okay? So our answer is x cubed. So I have another example.
A question.
Yes, please.
Explain dx. The one that you used there.
I explained dy dx. Okay. Let me go back again. So what are we differentiating? First thing first. What are we differentiating? Is this function?
Yeah.
Yes.
And what is this function?
Y.
That's why we write here 1. Okay? And again, we are differentiating this function with respect to
X.
That's why we write d of x.
A question. Not understanding.
Who is not getting up to that point? Okay? Please talk.
I'm not getting like the whole of it.
I think I'll give us some YouTube videos. They are more practical. I think we'll grab something from there.
A question. Why there you wrote fx and here you wrote dy?
Because I assume here we were not given these functions. Okay, in simple terms, this is a function of x. And this function of x, we call it what? Y. At this point, we were not dictated what will be the function of x now. It can be the function of x, it can be n, it can be y, it can be z, it can be o, it can be any letter that you choose. Now sometimes a question can come, differentiate the following function, x, 5, x cubed, and we have anything, okay? So that's why I decided to call this function to be function of x. But at this point, we've been given our function of x to be y. Okay?
Yeah.
That's why the man nimeandika dy. But kama hapo hujapewa, utaandika hivi. My d of f of x with respect to x. And now differentiate. Are we there again?
Understood.
Yes. Okay, never try. So up to this point,
Yes.
so I want to give out one example, and then pick one of you to come and try it. Okay? You just use the same procedure. So Don't be scared. These things are very simple. Our next example here, let me give a very simple example. A function of x, telling which is equals to y, is equals to x raised to minus 2. Who can come and try that? Guy, please. Can you try? You can just follow the same thing procedure. Identify the exponent. Okay? Patrick. Tell us what is the exponent and what you do to it. Just tell us the whole process of power rule differentiation. Explain to your.
So we're trying to to differentiate y in respect of x. So it will be dy over dx equals to pick your exponent to be your negative 2, bring the x down, the x, then initially it was negative 2, so it will be 3.
Show us how it has come to that point. Don't jump a step. Show us step by step how we arrived to negative 3. Show them.
Negative 3.
Yes.
Initially it was negative 2.
Yes.
You
write that there.
Then you subtract 1. So it becomes negative 3.
Okay.
Yeah. So that's our y.
So that's understood?
Yeah.
So let me give you the next example of the next person. We are going in order. So this one is a bit more tricky, but you can handle it. The square root of this one. Can anyone of you try? Jai? You can think. It's so simple, but not tough. Just come and try it. Just come and try anything. Yes.
Yeah, we have a very complicated one.
Yes.
We'll try. So it will be dy. It will be dy over dx is equals to x square root of x is it can also be written as half being the exponent. And then now we come to differentiating now this, and differentiating this we'll do we'll bring this down as coefficient of x. So it will be half x, and then we will subtract 1 from this, from half. Subtracting 1 from half, the process is half minus 1, which is the LCM is 2. So here you get 1 minus 2, because here is 2, here is 1. Okay? So here you get negative half. So you bring here negative half. I don't know if I'm right, but
Yes.
this would be our answer.
Very good.
Yeah.
That's a very
Yeah.
So we began from simple to complex. Yes, any question? So generally, when given such a complex function to tackle, what you do first, rewrite this